So in our last couple of slides here in the Desmos activity, what I want you to practice is trying to get, if you scroll over there, trying to get this parabola to line up its vertex on that point right there. So the vertex, we want to change our graph so the vertex is at that point. It's really just going to take a not very difficult to do, but it's going to mess with your brain just maybe a little bit, right? So you want to think about, okay, if I'm at 1, 1, I definitely need to go to the right, which means my h value needs to get bigger. Okay, now we're lined up on h, and my k value needs to increase as well. So notice my h is 2 and my k is 3. That was my vertex, 2 comma 3, right? So hopefully you're putting that together. If you move on to slide 9, we're now going to say, hey, if your vertex is 3, negative 4, right? If your vertex is 3, negative 4, then what would your h values be? What are the values for h and what are the values for k, right? So all you have to do is really think about, well, just like I looked at here, if I made my h2 and my k3, that became the vertex, right? So if that's the case, the h has to equal what in this case? 3. And your k has to equal negative 4. So that's what we're looking at here, is trying to make sure you understand that the h and the k from the equation, remember, the h and the k from the equation is this equation here, right? It's that equation. We want to make sure we're following that. So be very, very careful that you recognize how H and K really interact. So if we come back, let's try another one. All right, my screen isn't responding. There we go. So if we move on to slide 10, right? What do you think your H and K would be here? I'm not even going to tell you. What is your H and your K? Take 30 seconds, press pause if you have to, but type that in for me. You should have ended up with your h equals negative 2 and your k equals positive 1. It's really straightforward. So the last thing I want to point out here is this question. What effect does the value of a have on the location of the vertex? Right? What effect does it have on the location of the vertex? And the answer here, if you're not sure, is you can go back to whichever of these slides you want to kind of manipulate things. So here's my vertex. It's at 2, 3, right? And I'm going to go ahead and make sure it stays labeled, right? And if we zoom out here, and then I move the A value, I can make the A value whatever I want, and the vertex doesn't budge, right? It doesn't move anywhere. So the truth is that your A value, if you come back to our last slide, the A value doesn't have any effect on the vertex whatsoever. Has no effect, right? Has no effect on the vertex. That's a really important observation, that the A value can be whatever it be. Now it does affect the shape of the parabola, but it doesn't affect where the vertex ends up being. Okay, so let's use all of what we've talked about to come back to this final screen here. It's at the very bottom of your investigation. And what I want to do is I want us to think through what the roles are of H and K and try to do this for one equation altogether. Okay, so I'm going to write on my computer screen here. It's not going to be near as good as it usually is, but let's see what happens. Let's start out with the value of A, right? The value of A in this case is negative 2, correct? So our A value is a negative 2. What does that do? What does that do to our equation? What does it do? Is there a reflection? That's the first thing. Is there a reflection? The answer to me would be definitely yes, right? We definitely have a reflection. Ooh, look at that. That was nice. Okay. We definitely have a reflection because our A value is negative. Okay. The second thing that it's going to do is it's also going to make our graph, because it's further from 0, it's also going to make our graph narrow. right? Let's see if I can recognize that one. It's going to make the graph narrow. So the further we go from 0, it's not going to be extremely narrow, but it's going to be narrower than if it was like 1/2 or something like that. Last but not least, let's identify where the vertex is. And this is where we've got to be really, really careful, because we're probably going to look at this vertex. And if you're not careful, you're going to look at it and you're going to say negative, let's think, oops, I clicked the wrong button. You're going to say 8, -7. And that's the most common mistake, is that people go with 8, -7. When you are forgetting, if you do that, that the H value is the opposite of what you see, right? So it's not 8, -7, right? It's not going to be 8, -7. It's actually going to be -8, -7, right? Because it's the opposite of what we see, it's going to be -8, -7. Whoop, that did not work, did it? Let's try that again. Okay, I'll just leave it in orange. -8 and -7. So the opposite of what we see for the H value, and the same as what we see for the K value. That's what's important to be able to identify when we look at an equation in vertex form.